we're going to factor a difference of cubes. And a difference of cubes always has this pattern. It's a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So how does that work? Remember that, first off, a cube, or the cube of a number, a cube is a times a times a. For example, 2 cubed is the same as 2 times 2 times 2. Another cube, for example, might also be x cubed. Remember, that just means x times x times x. So with this in mind, let's actually factor the difference of 2 cubes. For example, what if we write this as 8 minus x cubed? Okay, in this problem, what we want to do is, first we see that x cubed, this is a cube. But what we need to find out is 8 can also be written as a cube if you write it as 2 raised to the 3rd power. So now what we do is we follow our formula. The formula would be like this. The a, this a right here, is the 2 in this case, and the b is the x. So if we follow this pattern, then we're going to have parenthesis 2 minus x parentheses. Then it says to take the 2 and square it, plus, then it says 2 times the x, plus take the x and square that. And let's clean that up. One more step would be 2 minus x times 2 squared, that's 4. And then 2 times x, we more simply write it as simply 2x plus x squared. And that's how you would factor a difference of cubes. Let's try another one. Let's try this. Try to factor a sum of cubes. Now, the problem with factoring these is that they don't follow the pattern of being able to play the game. What you have to do is you have to be able to recognize that this is a difference or a sum of cubes. So a sum of cubes would be something like a cubed plus b cubed equals, this has the pattern of a plus b times a squared minus ab plus b squared. Okay, so let's try an example. How about this? How about we factor, so let's factor y cubed plus 27x cubed. Well, the y cubed is a cube, and that's easy to see. But the question is what about 27x cubed? Is this a cube? Well, here's what we can do. If we notice that you can write 27x cubed as 3 times x cubed, then we've created a cube. So the y now is like the a in our equation, and all of the part in parentheses, all of this is the b. So using the pattern, now we can just follow our pattern. Here we go. So I have parentheses, the a is the y, then I use a plus sign, plus, the b is all of this, it's 3x times, then I take the a and square it, well that's y squared, minus, then I'm going to take the y times the 3x, plus, and now we're going to take the b, which is 3x, and square that. And when we do this, we clean it up with y plus 3x times y squared minus 3xy plus 9x squared. And that is how you can factor a sum of cubes. Now, there's one more thing to remember, and this is a mnemonic device. And a mnemonic device is a memory aid. And here is what some people do to better remember the patterns. So here's a cubed minus b cubed equals, I'm going to leave some space, a minus b times a squared plus ab plus b squared. And then I'm going to put down below it here a cubed plus b cubed. This equals a. Now watch this. All of the letters are exactly the same. They're all the same. And the mnemonic device that people use is this. It's SOAP. S-O-A-P. And what it stands for is same. So the same means that this sign always matches the first sign. This sign always matches the first sign. So we put a plus. The O stands for opposite. In other words, since I have a minus here, I use the opposite sign here. And since I have a plus here, the opposite of that would be a minus. So let's put our minus there. And then finally, the AP stands for always positive. And this always positive refers to the final position, both there and there.